want to make sure we cover this for AP Calculus AB, the second derivative test. And what I want to do right now is kind of go over the basics of this thing, and then I want to make sure that we're that we agree that we're in an understanding that the second derivative means much more than just points of inflection. So let's take a look at it first. So let's just see if we can find the points of inflection of f of x is equal to x cubed plus 3x squared plus 4. So what we're looking for is the second derivative, right? This is the second derivative test, so we need a second derivative. So the way that you take a second derivative is as obvious as it seems. The first thing you do is take the first derivative. And we will be doing some tests with this first derivative. However, the topic right now is just this second derivative test. So the first derivative of this would be 3x squared, wouldn't it? Plus 6x, right? And the first derivative of 4 is 0, so that goes away. So here's our first derivative, and we could do some tests here. However, we're not. So let's just take the second derivative, f double prime at x. And so the second derivative is the derivative of the derivative, so 2 times 3 is 6, so 6x plus 6. First thing I would do here is I would ask myself, is there any place that this function is undefined? And there's not, because the function is polynomial. And if you're confused about what I mean by that, if our derivative came back with something like this, well, we would see that x is 0 would have an issue, right? But we don't have that. Our function is polynomial and therefore differentiable on the open interval. So I guess the next question goes, for the second derivative test, is when is f double prime at x equal to 0? So this is f double prime at x. So when is that equal to 0? And we would find that it's equal to 0 at -1. So what we're looking for today is just points of inflection, right? And I'm even nervous saying this because what I should be saying is what are possible points of inflection, because we really have to do a test here. But that's not what we're going to do for right this second. Now we're just going to go through kind of the algorithm of how you would find this. So we know that at x equals -1. So we want a point of inflection, so we need an x and y value. So we have -1, and then we want f of -1. So we want f of -1, and somebody out there is going to take the first derivative of that, or the second derivative of that. That's not true. We want to know the position. Where does this inflection point occur? And when we substitute in -1 here, I think we get back a value of, what do we get a value back of? Of 6, right? So we get back. So that would be our point. So thus the point of inflection for f of x is the point -1,6. So this is our point of inflection. And that's all we got here. I'm going to do the next video, and I want you to pay closer attention because we need to go back and figure out this idea of PPI, or PPIs, the possible points of inflection, and how do we know if something truly is a point of inflection or not. But for now, that's our starting point. So take good notes, please.